Welcome to our next example using difference quotients. X cubed. All right, higher powers of x. Well, there's going to be a nice tool that we're going to use for this one. So let's get started. So we have f of x plus h minus f of x all over h. Okay, put that 1 over h out front. Now we're going to have an x plus h all cubed minus x cubed here. Now some of you might be able to expand this cubic, right, very, very quickly, and some of you might not. So let's expand, and then we'll talk about why it happened the way it did. And there's ways to maneuver that. So we have this, let's see, 1 over h out front. This becomes an x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. Okay, we'll finish and we'll talk about the expansion. So x cubes reduce nicely. Everything else has a common factor of h, so we'll pull that out. And we're left with a 3x squared plus 3xh plus h squared. These h's out front reduce nicely. And so really we have 3x squared plus 3xh plus h squared. Okay. This step, though, this is where some students have a little bit of difficulty. Basically, when we're doing the x plus h all cubed, right? We're doing x plus h times x plus h times x plus h. And you can multiply that out longhand to get the same result, or you can do the following. You can look at something called Pascal's triangle. There's also something called binomial coefficient. And Pascal's triangle is simply just you start off with 3 ones in the following fashion. So first row is a 1 and the second row is 2 ones, but they're sort of just off to the side of the first one. And the next row would be a 1, 2, 1. Next row is a 1, 3, 3, 1. Then a 1, 4, 6, 4, 1. And pretty much what we're doing is each time we're sort of, to get the inside terms, we're sort of just adding the 2 terms above it. So just in the previous row. And then, of course, on the outsides, it's just 1s all the way down the edge of the pyramid or the triangle. Now, what is this getting us? Now, this triangle does go on as long as you need it. So, you can do 1, 5, 10, 10, 5, 1, and dot, dot, dot. What is this getting us? Well, it turns out this is related to binomials. If you do a plus b to the 0, you get 1. If you do a plus b to the 1, you just get a plus b. If you do a plus b squared, you get a squared plus 2ab plus b squared. Notice the coefficients. 1, 1, 1, 1, 2, 1. Right? They're actually telling you the coefficients for the a's and the b's and the power, the powers associated with them. And so this 1, 3, 3, 1 is actually for if you do a plus b all cubed. And what happens is you can start the highest power of a you would get when you multiply it out, which is a cubed. That gets a 1 on it. You count down the powers of a, up the powers of b, and put the coefficients on. So you get plus coefficients of 3. You get an a squared, count down the powers of a. Count up the powers of b. We had a b to the 0 before, now it's a b to the 1. Plus then a 3ab squared plus a b cubed. Similarly, you can do it for the next row as well, right? If you did a plus b all to the 4th power, you can multiply out longhand and check this, but you should get a to the 4 plus, then we have a 4a cubed b plus a 6a squared b squared plus a 4ab cubed plus a b to the 4, and etc., right? You can do it to whatever level you need it. So that's one way to use Pascal's triangle to help yourself out when you're expanding powers of a binomial. Now for alternative difference quotient. So we have f of x minus f of a all over x minus a. So this will be equal to, we'll just have x cubed minus a cubed all over x minus a. Turns out you can factor the numerator. The numerator factors as x minus a times, and becomes an x squared plus ab plus a squared. That's all over x minus a. So now these two factors can reduce out nicely. And you're just left with the x squared, oops, not ab. That's supposed to be ax plus ax plus a squared. Now you might be asking, why can you even do this factor? Well, one of the things is that a is a 0 of that cubic on the top, right? That x cubed minus a cubed has a 0 of x is equal to a, which, using your knowledge of polynomials, this is going to yield that x minus a is a factor of x cubed minus a cubed. And then after that, you can do synthetic or long division to get the result. Some people have also memorized how to factor a difference of perfect cubes. Also, some of perfect cubes you can factor as well. But that's something to think about. All right. We'll stop there and then start looking forward to the next example.